far into the weeds and writing different equations and lines. Today specifically we're going to talk about two special cases of lines. And we're going to build upon what we looked at last time with two special slopes, and we're going to build the equation lines off of those. So the two special slopes that we looked at the last time is, well, if the slope was equal to 0, in which case we have a horizontal line that looks like this, or if the slope of the line came out to be undefined, in which case we would get a vertical line that looks like this. Undefined slope straight up and down, 0 slope horizontal, flat left to right. Now when we build equations of lines with either a slope of 0 or an undefined slope, they're really the easiest type of lines equations to build. The other types of lines require us to find a whole bunch of different things, including slope and then the y-intercept or some point that exists on the line. But let's say for the sake of discussion, we have 2 points here that sit upon the line. Point A is at, let's go 2, 4, and point B sits on the line, let's go 5, 4. And from what you looked at last time with slope, you should tell readily, well, because the y's have the same exact value, namely in this case 4, we are going to have a slope case of 0. It's going to be a horizontal line. We can see that graphically by plotting the 2 points. Here's 2, 4. Here's point A. Point B is at 5, 4. Here's point B. And if I connect the 2 dots, clearly we have a horizontal line situation in which the slope would be 0. From a mathematical standpoint, again, a good review of slope, it's always y2 minus y1 over x2 minus x1. Again, we want to work towards just having that burned in our memory. There's a handful of things that you have to know mathematically as a math person. Slope is one of them. It's like multiplication tables. You have that burned in your memory. You don't have to figure out anymore what 3 times 4 is. It's just automatic. It's 12. And then same thing with slope. It's not, well, what was it again? It's going to be for you, it's y2 minus y1 over x2 minus x1. Rise over run, y's over x's, etc. It just jumps out at you quickly. So here we go. If we were to calculate the slope, we'll call this the second point. So 4 minus 4 for the top. 5 minus 2 for the bottom. It really doesn't matter because you're going to get 0 in the numerator, 3 in the denominator, but anytime you have 0 divided by anything, the answer is 0. Hence, mathematically, it does come out to be 0. But here's our equation. And notice, no matter, this line goes on forever in both directions, no matter where we are on this particular line, you notice that the y value will always be 4. The y value never changes. It's constantly 4. So the equation of a horizontal line is simply y equals 4. Whatever the y value happens to be is going to be the equation that matches that line. So every horizontal line or line that has a slope of 0 has the equation y equals some value, some number. So if I'm asking you to sketch y equals negative 6, well, that means it's a horizontal line at negative 6. So here's negative 5, here's negative 6, and here's what the graph of y equals negative 6 is. So I'll draw it in blue since I found my blue marker again. So here's the equation or the graph of the line y equals negative 6. The slope is 0. We know that because it's a y equals equation, and then the value negative 6. And again, if you were to pick any 2 points on this particular line, this point here is the point 1 comma negative 6. This is the point, looks like 4 comma negative 6. And you could pick any 2 points. You would get the slope value to be equal to, well, negative 6 minus negative 6 all over 4 minus 1. If you were to calculate that slope, you get 0 in the top, because again, negative 6, subtract the negative 6 gives you negative, negative becomes positive, and then negative 6 plus 6 cancels out to make 0 on the top, 3 on the bottom, but again, doesn't matter. Anytime 0 is on the numerator, it's going to be 0 slope. So anytime that we have a situation that has a 0 slope as the slope of the line, it's horizontal. It's going to be whatever the y values are for that particular equation of the line. It's going to be y equals -6, y equals 4, whatever the case may be. So back here, when you have a horizontal line, 0 slope, the equation of the line that you will build will be y equals, and I just write whatever the y value happens to be. If I have 2 points, for example, A and B, and point A is -5, -3, and B is 2, -3. Well, the equation of the line that connects these 2 points together, so line, and this is the way we write lines in the math, AB, this is the line AB that has these 2 points. The equation of that line will be y is equal to -3. If you had to graph that line, we would go to -3 on the y-axis. I'm going to draw it dottedly. So here's the graph of y equals -3. Horizontal line at whatever y value it is, and then boom, that becomes the equation of the line. All right. The second type of special slope that we looked at in the last lesson was, well, what happens when the slope was undefined, aka no slope. I prefer undefined. People get confused, students do, with no slope and 0 slope. They are very different, but use undefined. It's just, it sounds cooler math-wise, you know, it's undefined. And that means for us it's a vertical line. So in terms of what that looks like on the XY plane or graphically, it's taking time to focus here. Maybe he doesn't like the undefined. Let's say we have 2 points once again. I'll use the letters C and D just to mix it up a little bit. Let's say we're at the point 2, 5, and D's at the point 2, -3. If I were to plot those 2 points on the XY plane, here's point C at 2, 5. Put a little dot there. We'll call that letter C. Letter D's at 2, -3. We'll put a little dot there. We'll call that point D. Connect the 2 points together, and there's my vertical line. And by default, we know that, well, all vertical lines have undefined slope. The slope is undefined specifically because if I were to calculate the slope, again, y2 minus y1, so -3 minus 5 over 2 minus 2, x2 minus x1. I'll get in the numerator, good review of integer work, -3 subtract 5 means, well, you're going to have a bigger negative, so -8 over 0. And the fact that we have 0 in the denominator, anytime we have 0 in the denominator, that becomes an undefined value for us because we never ever divide by 0. That's why the slope is undefined. All undefined lines have vertical graphs like this, and the way we write the equation of such a line that has undefined slope is, well, if you notice, everywhere along this line here, it will share the same x value. Whether I'm at here point C, I could be at this point here, which would have the value of 2, 3. This is 2, 1. This is 2, -1. It always has the same x value. We would say the equation of such a line is x equals, in this case it always goes through every x value at 2, hence x equals 2 is the equation of the line. It's a very similar situation that we saw just a moment ago with our horizontal lines. The unique feature in the horizontal lines is that they all share the same y value. No matter where you are along the horizontal line, you have the same y value. Therefore, the equations of those types of lines are y equals equations. All right, and they're easy equations to deal with. As soon as I see an x equals equation, like for example, I'm given the equation, let's say they say sketch the graph of x equals 12, well, as soon as I see x equals a whole number or a value like 12, I know right away this is a vertical line at 12. So I go along the x-axis to 12, so that'll be here. I draw in my vertical line this way at 12, and this is the graph of the equation x equals 12. If I wanted the graph of y equals 12 versus, y equals 12, they're different lines, right? X equals versus the y equals. A y equals is an equation or a graph of a line that is horizontal, that has 0 slope. So I would go to 12 here if I had to sketch that graph, and here's 10. It's going to be kind of off the page here at the very top. Let me pull this down, make sure we can see it. This way, like that, and here's y equals 12. So the equations are very different. An x equals equation is a vertical line up and down. A y equals equation is a horizontal line straight across. Any vertical line, an x equals equation has undefined slope. Any horizontal equation has 0 slope. Those two types of equations and lines always give my students problems in terms of writing the graph of them or sketching the graph of them, but I hope that kind of clears that up in terms of undefined, no slope. It's x equals some x value. Slope is 0. Horizontal line, this is 0 slope. And it has a y equals some y value equation. So x equals a number or y equals a number. And I say number more specifically because we've only dealt with whole numbers so that we can graph them nicely on the xy plane. But you could just as easily have a situation where you are dealing with an equation of a line that isn't a nice whole number. And it doesn't matter. If you have the equation of the line that has, let's say, for example, x equals 1.5, that just means it's a vertical line. I tell that right away because it's an x equals equation, no slope. So I go to 1.5, put a little dot there, halfway between 1 and 2. And if I were to sketch that line, it's just a line that goes through 1.5. It could be 1.7. It could be x equals pi as a graph. That would be a value a little bigger than 3, approximately 3.14 for what you've been using. You could graph anything. Y equals 7.42. That's a horizontal line at 7.42, so halfway between 7 and 8. So it would be something like this. Here's 5, 6, 7. 7.42, some graph that looks like this. Horizontally, there's y equals 7.42. Right there. That's kind of messy, sloppy. There's a graph of y equals 7.42. So it's any value, really. Any, we call them constant terms in math. No variables attached, just a number. Y equals a number, well, x equals a number. So again, memorize those or help familiarize yourself with the values of x equals y equals graphs. Horizontal vertical lines are pretty straightforward. And we'll talk to you later.